Okay, so hi everyone. Hope you're doing well. We're gonna do like a quick presentation, not too long because everyone's waiting for the coffee break right now. So we came here today to present our project, which is called Leveraging Annotated Data with Self-Supervised Learning for Continuous Recognition, Application to French, Belgium, Sign Language. So maybe that doesn't inspire you yet. There's like a lot of technical words, but don't worry. If we do our job correctly, you'll be as excited as we are about this project by the end of this presentation. So just stay with me for now. So the main idea is that we will be using deep learning for sign language. Okay, so that's your lifeline during this presentation. So you've probably heard of natural language processing, of course, but what about sign languages? So in the title, we talk to you about French-Belgium sign language. The Belgium here is important because you may not know it, but there's a lot of variety in sign languages. So for example, the French from Belgium and the French from France are two completely different sign languages. So you may begin to understand the problem that we have here, which is data scarcity, as we have a language with not a lot of people able to speak it. So we do have a corpus, which is just a fancy name to say that we have a data set of video of people signing, but this corpus has only a third of it with annotation. So an annotation, a label, is just a translation of the sign in the video. So only a third of the corpus is annotated. So why is it a problem? It is a problem because current techniques are using fully supervised learning, and fully supervised learning requires label. So as you may have guessed it, we can only use a third of the data set with this technique. For those of you that think, but you can just annotate the 2/3 that is not annotated. So just so you know, it takes roughly 100 hours to an expert to annotate 1 hour of video. So it's really time consuming and you need an expert. So we need a different approach to that problem. And this is the reason why we want to explore a solution with you, which is self-supervised learning techniques. So that no, you don't rely on the label and you can actually work with the full data set that we have. So now if we go back to our title, hopefully you understand the importance of leveraging annotated data. You understand that the solution is self-supervised learning techniques, and you understand why we talk about French-Belgium sign language. But we haven't talked about continuous recognition yet. So the idea with continuous recognition is to process uninterrupted sentences, so videos, rather than just working on isolated and individual sites. So to tackle this project, we have gathered quite a dream team because we have a lot of experience in sign languages processing, computer vision, self-supervised learning, and we even have a linguist with us, which is going to be really valuable for that project. And as you can see, I'm not Pierre, and Pierre is the team leader, and he's there with me today to present you our amazing work plan for this project. So Pierre.
So, hello everyone, I'm Pierre. So, I will answer the question, what are we going to do? So, first of all, we already have data, so it's already processed. So, the data processing step is not the big issue here. It's more about the modeling, about the deep learning part, the fun part for a lot of people. So our goal is to leverage unannotated data. So how do we do that? So first step, we want to train an autoencoder, so a VQVAE for the people who knows it. So the goal here is to compress the data to get a lower dimensional representation, but that's not all. After that, we want to improve that representation. We want to force the model to contextualize the data. So we want more semantic into the representation, because in sign language processing, in all the tasks where you have a lot of similarities between frames, for example, you really need that step. So after those two model packages, so compression and contextualization of the data, you can evaluate your representations on a downstream task. For example, in this case, the continuous sign language recognition. And so that's really quite a classical pipeline, but that has never been applied on the French-Belgian sign language. And there are not so many papers, even in sign language processing, about that pipeline. And in addition, we really would like to improve the contextualization part by using more modern approaches that are becoming quite popular in other fields, such as video generation, but they have never been applied in sign language processing either. So we are really aiming to try methods from different fields for sign language processing. So if you really like deep learning, I think if you really like computer vision, especially advanced methods, and a bit of natural language processing, you will like this project. So, what kind of people we are looking for? Really, I mean, we can adapt. If you have a background in software engineering, it's fine. But if you're really interested in deep learning, especially with PyTorch, because that's the main stack we're using, you're welcome. But we're really in the intersection between NLP and computer vision, so we really take methods from the two fields. So thank you. Do you have questions?
Do you have any question? Yes?
Yes.
What kind of model are you using to process your data?
To process the data, to extract the post data?
Are you using MediaPipe?
Yes, we are using MediaPipe, but we could use other ones too. But the data set is already processed with MediaPipe because we got the best results with those ones.
Okay, and I mean, precision for MediaPipe is like 80% maximum on the fingers. Even if you are far away,
Yes.
so are you aware of like fall detection, misdetection, and so on? Because
Yes.
I think it could be a dramatic problem for your project.
I mean, that's a project for sign language processing, the quality of post data. But even in fully supervised methods, like you have a lot of issues. For example, with when you have DMs that are hiding one another or stuff like this. We are aware of that, but fully supervised methods, they work quite well, even if there are issues. But that's another field of improvement. But we are really focusing on how to embed the unannotated data in the pipelines.
And
we are aware of this.
have you planned to, I mean, work out also on the how can we mitigate for mistakes, issues, or from the post estimation?
Yes. To be honest, that's not really the focus in this project, but we could work on that. If there are several methods, we can talk about that a bit later because there are a lot of them. But yes, there are ways to deal with that issue. Yes.
Okay, we won't be much longer before the coffee break.
Yes.
So I propose everyone to go to the coffee break. We should go back here at 11, let's say 11 and 5, so that we have some time. See you. Thank you.